I welcome you all for another brilliant presentation on control system subject. In today's presentation, I would like to explain about the another a very important topic or chapter otherwise from control system subject, that is the concept of stability. It is a very important topic, and 99% you will be expected the questions from this concept of stability in gate examination as well as IAS examinations and in many uh, state and central technical competitive examinations, right? The concept of stability, very brilliant topic, very interesting topic, and definitely you will enjoy this topic actually. So basically there are two techniques are employed under this concept actually. So in this topic we are going to see what is a stability, why it is required for a control system, how the stability of a system can be determined or can be estimated, what are the different types of stabilities that we will see under these two classifications. Basically there are two classifications that we will see while discussing our subject. Yeah, I welcome once again you all for another brilliant presentation on control system subject, in which we are going to see the another beautiful topic, and in fact it is a very excellent, very important topic, and most of the question or you will get definite questions from this topic. It is concepts of stability. Concepts of stability. In today we are going to see the lecture number 54, in which we will see the concept of stability. What is stability? What is stability means? Why it is required in a control system, right? And what are the various techniques are employed, or what are the various techniques that can be applicable for a system to determine or to estimate the stability of the given control system, right? This is another beautiful and very interesting, very very important topic that we need to learn and we need to consider, right? I hope you definitely will enjoy this, right? So let us go into this, the concepts of stability. What does a stability means actually? What do we mean by a stability? Stability means stability means being in a active condition. That is meaning of a stability. Stability means stability means being in a active condition. Being active means being responsive. Responsive. So being in active condition and then being responsive. That is what stability. So any system, if it is said to be a stable system, then definitely that system must be in active condition, means it must be in on condition, rather than it should not be in off condition. So if the system is in off condition, then we will not expect anything from it at the output stage, right? Though you apply the input, say for example, for your understanding I will write this is a system. Normally what we can represent like this is a system, right? For this, say for example you are giving some input r of t, and this is normally we must get our output as C of t, no? Normally our output is C of t in general, as far as our control system subject is concerned. Say, for example, you have put this system under off condition. You have switched off actually. The system you put under off condition, you are giving some input here. You are giving some input, but the system you kept off condition. What you will get here output? Nothing, zero, no output, no output. In this case, this is called as inactive. This is called inactive. The system is called inactive condition. Inactive condition, or otherwise also called as, this is not responsive, unresponsive or not responsive. You will not get anything at output, no response. You will not get any response at the output because the system you put under off condition. And in this case, you can call it as, it is not stable system. It is unstable, you can say. It is not a stable in the sense, once if you get some output for the given input, then only you can tell about the stability of the system, right? So once if you put the system in off condition, there is no question of discussing about the output, nothing. Clear? That is what sometimes it happens, knowingly or unknowingly. Normally we will do something by switching off the actual system, and finally we'll feel that array, we have not got the output. Yes, it will happen normally, but as far as our subject is concerned, right? So stability is a very important characteristic that need to be considered for any control system, and moreover, this concept of stability is definitely belongs to the linear system. Most of the times this will be applicable, this stability is employed for linear systems, right? That's why, say for example, the system is also called as linear time invariant system, or simply you can call a system. That's it, right? Say for example, let us consider this particular diagram again. Let us consider this diagram again. This is our control system. This is our control system, let us say. This is my input. This is my input, call as R of t. This is my output, and I will represent it as C of t. Clear? And also, input is also called as excitation. EXCI TATION. Excitation. My output is also called as response. This already you know. So the very important definition of stability, the very important definition of stability is nothing but the system, the control system, or most of the time we will consider this definitely a linear time invariant system, okay, or simply a control system. For any given control system, once the applied input is a bounded one, if my input is bounded by, if the applied input is a bounded one, bounded means limited, or otherwise you could call it as finite. It should not be infinite, no, it is a finite value. Therefore, if the applied input signal, or if the applied input is a bounded one, then the system should provides, or the system should gives a bounded output. It gives your output as bounded output. You will get bounded output. So if the input is bounded input, or otherwise you can call, most of the time it will write BI, bounded input. If the input, whatever you apply at the input stage of the system is a bounded one, means a limited one, or it is a finite one, then the system gives at the output bounded output, BO, bounded output, bounded output. So, if the input is limited, then obviously your output is also limited. If the input is finite, then definitely your output is also finite. Then only you will have certain linear relationship between the input and an output. Linear relationship. There must be a proportionality must be there. A proportionative relation must be there between input and an output. That is what the linear means. That is why the linear time invariant system came into the picture. That's why we all are studying about the linear time invariant system. Clear? Therefore, the input must be bounded one. The input, the applied input must be bounded one, means limited one. Then you will get the bounded output, means the limited output. Then the system will call as a bounded input, bounded output stable system, or simply this can be called as BIBO stable, BIBO stable system. Okay, this system is called as BIBO stable system, means bounded input, bounded output stable system. Okay, clear? Bounded input means a limited one. It is a finite one. If the input is finite, your output is also finite. If it is limited, output is also limited. That is the condition required. That is the condition satisfied or required in order the system to be a stable one. Stable one. That is the very first and foremost condition. Clear? That is the first condition. Right. Sometimes what will happen, if the input is given, say for example, the input is bounded, means you have given your input is a limited input you have applied to the system. Clear? You have given the limited input or finite input you have applied. But unfortunately, at the output, you will get, the system will provide unbounded output, not bounded. Instead of bounded, you will get unbounded, uncontrolled. Uncontrolled. The input is controlled only. You have given the controlled input, but you got at the output of the system uncontrolled output. Then the system is called unstable system. Right? Then the system is called unstable system. Clear? That is another very interesting and important definition to be remembered. And then one more important condition is that in the absence of the input to the given control system, clear? In the absence of the input means the input is zero. You have not applied any input to the system, then your output tends to zero. Means definitely you should not get any output. That condition also should be satisfied, right? So these are the conditions basically. Therefore, this is a very important definition, BIBO stable. That is the definition of a stable system. Because in control system, okay, it is very important and interesting parameter need to be considered whether the system is giving a stable output or not. That is very important. If the output is not stable, what is going wrong with the circuit? Means a system, as we have discussed in our earlier presentation, a system is a group of so many interconnecting or intermediate subsystems. Okay, it involves, a system may consist of so many intermediate subsystems. Very smaller systems will be there in between. Therefore, because of any reason, if anything goes wrong in between, any intermediate stage goes wrong, then you will not get the proper output. Then you need to check and cross verify stage by stage. Therefore, you can easily trace it out where the thing has gone wrong. then you can identify it, you can rectify it, and finally you will try to get the relevant, the desired output at the actual output stage of that particular system. Clear? That is what stability means the system must be under stable condition, then only the proper output should be obtained. Okay, so in fact or otherwise, the stable system gives the desired output. In fact, the stable system will gives you a desired output, noise free. I mean the less noise, you will get the less noise. Almost all noise will be there, some amount, some percentage of noise will be there at the output, but our topic is not regarding to noise here. It's not the main objective here, but to determine whether the system is stable or not. That is our motto, or that is our aim under this topic actually, right? Therefore, this is the basic definition of a stability basically, right? And then and then what are the criteria are there? Is there any techniques to demonstrate the stability of the system, or is there any procedures, or is there any methods to determine the stability of a system? Of course, there are very beautiful two methods are employed to determine the stability of this system. There are excellent methods are there. There are two important beautiful methods are there. The first one is Ruth Hurwitz criteria, ROUTH. Ruth Hurwitz criteria, or Ruth Hurwitz technique, you can say criteria or technique, whatever you call. This is what the next one is root locus technique. Root locus technique. Root locus technique. These are the two beautiful and important techniques that are employed, that are available to determine the stability of a given system. Therefore, these are the two beautiful methods basically. Ruth Hurwitz criteria, and then the second one is the root locus criteria, root locus technique. By using these two techniques, we will find out the stability of the given system. And again, there are different types of stability are there: conditional, or marginal stable, or limited stable. These are the varieties of definitions are there depending on the system's transfer function, right? So I think this is the introductory clause actually, presentation regarding these concepts of stability, and then we will finish off this presentation here today, and then we will continue in elaborate information about the Ruth Hurwitz criteria first, and we will see there are set of rules are there to find out the stability by using the Ruth Hurwitz criteria. We will see in elaborate about this Ruth Hurwitz, and we will do some examples, and later on we will move to the root locus techniques. And these are the two very important methods, and definitely in GATE examination and in UPSC IS examinations also. In these two, and even obviously in your academics also, in your university semester examinations or end examination, whatever it is, definitely they will ask from these two. But in competitive examination point of view, you definitely will get questions from this. Definitely you will get questions from this topic. You will definitely should ask questions from this topic. Very important topics these two are, and we will see in detail in our subsequent presentations, right? So thank you for watching, and we will see in the next presentation. See you. Have a wonderful day.